Okay, let's look at some distance, rate, time problems. So we've messed around with some parts of this, but now we're going to put it all together and actually set up equations and answer more specific questions rather than just setting up expressions. Okay, so let's see, in the whole problem, we have a plane that can fly 200 miles per hour. That's assuming there's no wind. We are trying to set up a 4-hour sightseeing trip. So we need to fly as far north as possible and then return back to where we started. So the first question is, if there's no wind, how far is the round trip? And in this case, it's actually a pretty simple question. We know that we go 200 miles per hour the whole time. We do that for 4 hours. So distance is equal to rate times time, which means we multiply the 200 miles per hour times the 4 hours. Hours cancel, we get 800 miles out of the deal. 400 north, 400 south. So nice and simple. Nothing in the problem is changing whether we go north or south. The second part is where it gets kind of interesting. In the second part of the problem, we now have a wind blowing. So we're going to start wherever we start, and we're going to fly as far north as we can and then have to come back south. And we know that the whole trip has to get done in 4 hours. The wind is blowing from the north, so assuming this is north and this is south, at 30 miles per hour, which means we're going to go slower on the way north than we do on the way south. So since we have to make a round trip, the distances have to be equal, but the times aren't going to be equal and the rates aren't equal. So this one gets a lot trickier and more interesting. Okay, so let's start thinking about what we need. We need a variable, and I actually think that's a really good place to start, so you know what you can represent with your variable and what you have to sort out some other way. This is a how far question. How far is the round trip? So if we say, what do I want to say? Here, big D equals round trip distance. Let's do that. So there's our variable. And then if we start looking at this problem, we basically have 2 parts. We have the trip north and the trip south. So let's summarize what we can about the 2 trips. One thing I know is that since it's a round trip, the distances have to be the same, which means the distance north is going to be half of the round trip and the distance south is going to be half of the round trip. So let's just summarize that for ourselves. Anything you can write down for yourself is going to be helpful. So the distance north is equal to the distance south is equal to D over 2. Okay, what else do I know? I know everything about rate. I know that the rate going north is the one that's going to be slower. So we have a plane that can go 200 miles per hour, but the wind is blowing into us at 30 miles per hour. So the plane's only going to be able to go 170 miles per hour. On the way south, we have a plane that can go 200 miles per hour, but the wind is pushing us at 30 miles an hour, so we can go 230 miles per hour. So rate's a nice one in this problem. We know everything that we need to know about rate. Hopefully I left myself enough room for this problem. The last thing is time. The only thing I know about time, I don't know how long we spend going north or south because they're not going to be equal anymore since we go slower on the way north. We can spend a little longer going north. We're going to make it up on the way back when we're going faster. The only thing I know about time is that the total trip takes 4 hours. That's all I can say. So I want to build an equation that includes my rate information and my distance information because that's what I know the most about. And this time statement is what's actually going to allow me to get that information in. So this is the structure for my equation. Everything else gets plugged into this. This is what I'm going to use to build the equation. So last thing I need to remind myself of is if I know distance and rate and I'm trying to get time, distance equals rate times time. So time is equal to distance divided by rate. So when I go to time going north, I'm going to take the distance going north, and I'm going to divide it by the rate going north. And that represents time. Time is distance divided by rate. When I'm going south, that's the same, d over 2 distance, and a different rate. And I know that that should equal 4 hours. And there's my setup. So that's the really challenging part. I know. I don't expect it to always just fall right out for you, but that's my advice for how to get yourself started. What are you being asked for? Define a variable. Start working through your information. These are distance, rate, time problems. So is there just one thing going on, or is it kind of like you have to split it up into 2 trips? List the information for distance, rate, time as much as possible. And the weird one where you don't have variables and you don't know the numerical values, that's going to help you build your equation. So let's see. I want to solve this ugly beast. I'm just going to multiply by both. This isn't going to be too bad. So I'm going to multiply by 170. 170. So I have to distribute on this side. I get d over 2 plus 170 d over 2 divided by 230 equals, what is that, 400, and then another 280, so 680. Okay, and I could probably simplify a little. Let's see, 170 does divide nicely by 2. What is that, 85? 80, 81, 60, yeah, 85. This is just an 85. Where'd that 8 go? There. You don't have to simplify there if you don't want to, but it seems like an okay plan. I could simplify more, but I think I'm okay with this. So now I'm going to multiply by 230 times 230. That one I'm not doing in my head, but I can say that 230 divided by 2 is 115. So right here, I get 115d. And when I multiply 230 by 85d over 230, the 230's cancel, and I just get 85d. And then on the other side, I have 680 times 230, which is 156,400. Okay, so this is looking a lot better. D's no longer trapped in fractions. I have D's on the same side, but I could still combine. So what do I have? 190, 200. That's actually going to work out really nicely. Equals 156,400. When I divide by 200, cross off some zeros. 1,564 over 2, so at 32. Oh, again, me and arithmetic today are not getting along. 64 over 2, 782. So the distance is 782. Always at the end of these, go back and think about what the problem was asking for and think about if your answer makes sense. So what did we have before? We could go 800 miles if there was no wind. We're getting close to that, but not exactly equal, so that seems reasonable. And this is a D value. So that's going to be distance in miles. Make sure you include your units on this. That's the one way that I can see that you went back and thought about what your answer means. So I will always check for those units. That's really important.